Now let's combine graphing both sine and cosine when we have changes to both the amplitude and the period. I'm going to show you in this first example two methods to be able to do that. Both methods are supported in the textbook. The first method is what I call the table method, okay, where we're going to have a series of steps that we go through and we're going to end up making a table of values. So let's get started. Here's the first example. We have y is equal to 3 cosine 2 pi x. And the very first thing that you're going to want to do is you need to find out what the period is of the function. Okay, so that part's not going to change. So the period of the function, in order to find the period, we have to figure out what b is. In this case, b is 2 pi. So if b is 2 pi, then the period of my function would be 2 pi over b, which would be 2 pi over 2 pi, which is just 1. So that tells me that the interval that I'm looking at now is just between 0 and 1. The next thing that I want to do is I want to make up the table based on this interval being broken up into fours. Okay, so we end up with 5 values. So we're going to come over here and we're going to draw a table. So I drew a table right here, and I'm going to fill this in by putting my interval values up here. These are the x values, or the values that I would break up the x-axis to be at. So I'm going to start at 1. I come down here, I'm starting at 0. I go to 1. I know that halfway in between that is 1/2. Half of 1/2 is 1/4. And then the other side would be 3/4. Okay? The next step in this table is to look at my function, and we are going to take the 2 pi x, and we're going to evaluate this portion right here for each of these x values. So in other words, I'm going to say 2 pi times 0, and that gives me back 0. 2 pi times 1/4. Well, that's going to give me pi over 2. 2 pi times 1/2. That gives me pi. 2 pi times 3/4. That gives me 3 pi over 2. And then finally, 2 pi times 1, I get 2 pi. So I took care of this portion first. Next, I'm going to say, well, what is the cosine of that? So it's the cosine of what I just found in that row right there. So the cosine of 0 gives me back 1. The cosine of pi over 2 should give me back 0. So the cosine of pi is -1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Finally, we're going to take 3 times whatever that was. So it's 3 times whatever I just found in the previous row. So this becomes 3 times 1, which is 3. 3 times 0, which is 0. -3, 0, 1. Now what did that tell me? What this ended up telling me is the ordered pairs. In other words, I can plot points now based on the top row here, which gives me my x values, right? Those are the values along the x-axis, as well as this row, the final row after we evaluated the entire function basically. Well, these are the y values. And because I have both x values and y values, I can write them as an ordered pair. So this ordered pair would be 0, 3. The second ordered pair, 1/4 and 0. 1/2, -3. 3/4, 0. 1, That's not 1 down there. That should be a 3, shouldn't it? So this should be 1, 3. Okay, so the second thing that we did in this was we created a table based on my interval that I created and then evaluating the function at that. Finally, we're going to graph the ordered pairs. So I'm going to draw me an x and a y axis that's broken up into these first values and has a maximum height of 3 with a minimum height of 1. So rather quickly, I come over here and I do that. I'm going to go up 3, down 3, negative 3. I break this up into 1, 1/2, 1/4, 3/4. So the first point that I'm actually going to plot is at 0, 3. So that's over 0 up 3. The second is at 1/4, 0. Then we have 1/2, negative 3, 3/4, 0, and 1, 3. And that is consistent with what we know the cosine function to look like when we graph it. And that's the first method. That's what I call the table method. Now, some people like that method and some people don't. So some people prefer to graph this function using translations. Remember, translations, which we'll really cover in the next section, translations are really all about just evaluating the function and figuring out if there are any shifts or what the amplitude and what all of that information is. So I call this the translation method, but we're really going to come through and we again go through a certain number of steps. The first one is to find what the period is. Well, if b is 2 pi, then the period hasn't changed from when I did it before, but we're going to pretend 2 pi over 2 pi, which is really just 1. So in other words, this is going to break up between 0 and 1. The next thing that I know about, well, and let's go back here. We know if it breaks up between 0 and 1, then the parts to this would be between 0, 1, 1/2, 1/4, and 3/4. So the second thing that I want to identify out of this, now that I know what the period looks like, is the amplitude. So the amplitude for this is 3, meaning that I'm going to go up a maximum of 3 and down a minimum of 3. So I can draw this really quickly based on that information. We know this is what my x-axis looks like. We know that I have a height of 3 and a minimum of negative 3. And because we already know what a cosine function looks like, we know cosine starts high, crosses the x-axis, goes low, crosses the x-axis, and goes high. Connect your dots, and there you go. So I was able to graph this function just by determining what the period was and the amplitude, as well as dividing it up into its intervals rather quickly by sketching the graph in that way. So let's look at one more example. And I'm not going to use the table method. I'm going to actually use the translation method that I just showed you. And we're looking at this and it says y is equal to negative sine pi over x. So we're going to go and we're going to identify our parts again. The first thing, remember, the first thing that I want to look at here says the period. So if b is equal to pi, then the period would be 2 pi over b, which is pi, or in other words, 2. So we have a new interval between 0 and 2. Okay? So this interval is going to break up to look like 0, 2. Halfway between 0 and 2 is 1. Half of 0 and 1 is 1/2. So the other side is 3/2. Okay? So this is what the x-axis is going to look like. The second thing that I want to look at in this function is the amplitude. Okay? The amplitude is actually 1. But this is why it's called translation. If you remember from translations, and if you don't, anytime I have a negative amplitude, then my graph is actually flipped. In other words, this graph is flipped across or reflected across the x-axis. So if my normal sine function starts and goes up like this, my flipped function looks like this. So now that we have an idea of what this is going to look like, we come down here. We break up our interval between 0 and 2. There's a 1, 1/2, 3/2. The amplitude is a positive and a negative 1. But remember, because it's flipped, we start at the origin, we start at the x-axis, but we go down, back to the x-axis, go up, and back to the x-axis. So because my amplitude was negative, we ended up with a graph that is reflected or flipped across the x-axis. In trig functions, with all of our trig functions, this flip only occurs across the x-axis. If you're remembering any flipping for other functions using translations, we don't have any of that. In trig, we are only talking about flipping this over the x-axis, and that's the only thing we're concerned with here. Okay, so those are a couple of examples of how we're going to graph sine and cosine by adjusting or when we have the period and the amplitude changed.